Have you ever looked at a river and just seen, well, water? Today, we're going to see them for what they really are, the most patient and powerful landscape architects on the entire planet. See, they aren't just flowing through the land. They are actively building it and taking it away in this constant epic cycle.
So let's just start with a mind-blowing idea. Huge parts of our world, places where entire cities now stand, they just weren't there a few thousand years ago. They were built literally grain by grain by the relentless work of a single river. So how on earth does that even happen? Well, that's exactly what we're going to break down.
You know, to really understand a river, you can't just look at the big main channel. You have to look at its entire family. And it turns out that seemingly chaotic network of little streams and creeks that feed into a river, it has this surprisingly logical structure, almost like a family tree.
Every single river on Earth is part of something called a drainage basin, and the tree analogy here is just perfect. The tiniest streams way out at the edges are like the tips of the branches. They're all collecting rainwater and runoff from the land and funneling it step by step into one main trunk that eventually reaches the sea.
So, geographers needed a way to make sense of all this branching chaos. They came up with a really simple but kind of brilliant ranking system called stream order. It's basically a way of assigning a number to every single part of the network, from the tiniest trickle all the way to the mightiest river.
And here's the beautifully simple math behind it all. Okay, so the smallest unbranched streams at the very start, those are called first order. When two first order streams meet, they create a second order stream. When two second orders meet, they form a third order. Now here's the key. If a small stream, say a first order, flows into a much bigger third order stream, the main river stays a third order. It only levels up when it meets another stream of its own rank.
Okay, so we've got the network. The plumbing is all laid out. Now let's talk about the real work. All that water gathering and flowing isn't just a passive journey. No, it is an active, powerful force that is constantly sculpting the planet by moving absolutely immense amounts of material. So a river's job can basically be broken down into three main tasks. First up, erosion. It picks stuff up, tearing away at its own bed and banks. Second, transportation. It carries all that material, which we call sediment, downstream. And finally, deposition. When the river slows down and loses energy, it has to drop everything it was carrying. Now, the really crucial point here is energy. Think about it like this. Lifting a super heavy backpack off the floor. That takes a lot of effort, right? But once it's actually on your back, carrying it is way easier. It's the exact same principle for a river. Getting that sediment moving in the first place requires a really high velocity, but once it's up and suspended in the water, a much slower current can keep it moving along. And get this, here's a totally weird paradox. You would think the smallest, lightest particles would be the easiest to pick up, but nope. Tiny clay particles are so fine that they actually bond together. They get all sticky. So a river often needs a stronger current to rip apart a patch of clay than it does to just roll a much larger grain of sand along the bottom. How weird is that? Okay, so we've seen how rivers gather water, and we've seen how they pick up and carry material. This brings us to the grand finale of the river's journey. This is the moment it stops taking and starts giving back, building entirely new land right before our very eyes. Right, a river can't just carry its load of sand, silt, and clay forever. When a river that's been flowing downhill finally hits the flat, open water of a lake or an ocean, its speed just drops off a cliff. It basically runs out of energy, and its job as a transporter comes to an end.
In the place where it drops all that sediment, that's called a delta. A delta isn't land that the river flows over, it is land that is made by the river. It's just a massive pile of all the ground-up bits of the continent that the river has carried, sometimes for thousands of miles. So why the name delta? Well, it's pretty straightforward. Ancient Greek historians looked at the mouth of the Nile River and saw this really distinct triangular shape. It looked exactly like their letter delta, and the name just stuck for all similar landforms all around the world. But here's the thing, not all deltas look like the Nile. Their final shape is actually the result of a massive tug of war between the river and the ocean. And depending on who wins that fight, the delta can take on one of three really distinct personalities.
So, there are three main forces battling it out here. First, you've got the river itself, trying to dump all its sediment and push the land further out. Second, you have the ocean's waves, constantly crashing and trying to smooth that coastline back out. And third, you've got the ocean's tides, the daily push and pull of water that can sculpt all that sediment into some really unique patterns.
Now, when the river is the undisputed champion, you get what's called a river-dominated delta. The classic example is the Mississippi. It just pushes these long, thin channels of land way out into the Gulf of Mexico, so it looks like a bird's foot. But when the waves win, they take all that sediment the river drops and immediately spread it out along the coast, creating a really smooth, arcing shoreline with lots of beaches, just like the Nile.
And the third type is where the tides are the boss. In places with a huge tidal range, that twice-daily rush of water in and out of the river's mouth is so powerful that it carves the whole delta up into a series of long, stretched-out islands, and they're all lined up parallel to the flow of the tide. You see this in the massive Ganges-Brahmaputra delta.
Now, it's really tempting to look at these deltas on a map and think they're permanent features, but that could not be further from the truth. They are honestly some of the most dynamic and rapidly changing landscapes on the entire planet. Their story is constantly being rewritten. See, a river is kind of lazy. It always wants to take the steepest, shortest path to the sea. And as a delta builds further and further out, its slope gets really gentle. Eventually, it's just easier for the river to break through its banks somewhere upstream and find a completely new, shorter route to the ocean. This is called delta switching. The history of the Mississippi River is just a perfect example of this. The bird's foot delta we see today? That's just the latest chapter. Over the last 4,600 years, the river has abandoned its main channel at least 6 different times, building and then abandoning these huge chunks of what is now the Louisiana coast. Each one is a former delta, a ghost of the river's past.
On average, the Mississippi gets tired of its old path and just radically changes course, about once every 1,000 years. And this is an ancient history. Geologically speaking, this is a constant, ongoing process of land creation and abandonment. So why does all of this matter to us? Well, because this whole process creates a paradox. The gift of a delta is its incredibly fertile soil, which gets renewed by floods. This is why great ancient civilizations, like in Egypt and China, all grew up on deltas. But the risk is that this land is barely above sea level, which makes the millions of people who live there today, like in modern Bangladesh, extremely vulnerable to flooding and storms.
And that really brings us to our final question. For thousands of years, these natural land-building factories have been the cradles of human civilization. But now, with rising sea levels and all of our human interference, many of the world's great deltas are in serious trouble. They built us. The question is, in this changing world, can we find a way to save them?